Welcome to this video on CyberArk and Azure VM integration, providing a comprehensive security architecture for enterprise privileged access management. Our mission objectives include secure governance for 10 admin users, full control over 50 Azure Virtual Machines, and automated credential rotation with zero manual intervention. The system architecture flows from admin users using SSO and MFA through the CyberArk PVWA portal and Privileged Session Manager to the Azure VMs via RDP or SSH. Network traffic flow is strictly enforced. Zero direct access is allowed, and the CyberArk PSM acts as the mandatory jump server for all management traffic. Azure prerequisites include proper subscription access, 50 targeted virtual machines with RDP and SSH open internally, and specific networking configurations like NSG rules and no public IPs. CyberArk prerequisites involve the digital vault for secure storage, the PVWA portal as a unified web interface, and the CPM and PSM for rotation and session isolation. The connectivity requirements detail the necessary source components, target components, and the corresponding port and protocol for secure communication. Step 1 is the design model. We define operational boundaries, security constraints, including identity provider integration, session isolation strategy, and the credential lifecycle policy. The access model definition specifies 10 VM administrators, 50 cloud instances, and automatic rotation every 30 days. Step 2 is implementing Entra ID single sign-on for seamless authentication using Azure Active Directory via SAML 2.0. This involves creating an application, assigning users, and enforcing MFA. Step 2.1 focuses on hardening by implementing Zero Trust Conditional Access. This verifies user location, device health, and MFA status before granting access to the vault. Step 3, Windows Setup, follows the best practice of using a dedicated local admin account for CyberArk management. For Linux setup, the account, commonly CA admin, is granted sudoers access. Management supports both SSH key and password rotation. Our hardening strategy requires disabling generic admin accounts and ensuring the CyberArk account can change its own password. Interactive login to the CyberArk account should be restricted. Step 4 is the Vault install. The core PAM solution must be installed on a hardened, standalone VM with no domain join, strict external firewall rules, and a strict outbound block. The PVWA and CPM setup involve installing the PVWA on a Windows server with IIS, configuring the HTTPS endpoint. The CPM, the worker service, performs password rotation on the 50 VMs. The PSM jump server is vital for proxying and recording sessions for audit. Key requirements include the RDS role, direct line of sight to Azure VM private IPs, and high-performance disk storage. We have two deployment models: self-hosted, where all components are on your Azure IaaS VMs, and SaaS, where CyberArk manages the vault and you only install the PSM connector locally. Step 5, Platform Logic, defines the rules for password rotation and session management. This includes defining password age, selecting the PSM connector, and enabling recording. The Windows platform design uses WinLocal Admin. Password change is enabled via WMIRPC. The PSM protocol is RDP, and auto-detect is enabled for new VMs. For Linux platform design, we use Unix SSH. Password change is enabled via SSH, and sudo usage is automatically utilized for management tasks. Step 6 is onboarding, which moves the 50 VM identities into the secure vault environment. This process includes logical safe segmentation, bulk CSV upload, and permissions assignment. Our safe infrastructure includes AZ-WinVM storing 25 Windows local admin accounts and AZ-LinVM storing 25 Linux SSH root or admin accounts. The Safe Permissions matrix details the access rights for different users and roles to ensure least privilege access. For bulk onboarding of Windows accounts, we can upload a CSV file to the PVWA to create multiple accounts simultaneously. Linux onboarding uses CyberArk Discovery to scan the Azure subnet and automatically find instances with SSH enabled, reducing manual errors and automating the process for future VMs. Step 7 is password rotation, which occurs at a 30-day interval. The CPM connects to the VM, generates a complex string, updates the VM, and securely saves the new secret in the vault. Complexity standards for passwords are rigorously enforced to maximize security. Step 8. PSM configuration involves enabling allow access via PSM on platforms, configuring RDP, InRDP, or HTML5 gateway, and verifying internal routing from the PSM VNet to the target VNet. A critical step is direct access block, removing any ability for users to bypass CyberArk by removing public IPs, blocking 3,389 20-seconds from the internet, and allowing traffic only from the PSM subnet source. A network security group, or NSG rule template, is essential to define and enforce these strict network security policies. Step 9 is setting up user groups, specifically the Azure VM Admins group, with the constraint that members can only use the PSM Connect button. Show and copy password buttons are strictly disabled. The connection flow allows the administrator to access the machine without ever knowing the password. The credentials are injected invisibly after the admin clicks connect in the CyberArk portal. Monitoring and recording includes full video of screens, searchable logs of all keystrokes and commands, and real-time alerting for forbidden commands. Live session monitoring allows security officers to join active sessions, observe behavior in real time, and immediately terminate suspicious activity. Audit compliance ensures we can answer key questions like who accessed the VM, when the session occurred, which commands were executed, and when the password was last rotated. Pro best practices include separating safes for production versus development, using one-time passwords, implementing dual control, exporting recordings to Azure Blob for retention, and integrating with a CM like Azure Sentinel. Common failures to avoid include leaving RDP ports open to the public internet, giving admins retrieve password permissions, managing Azure AD accounts inside VMs, and failing to test rotation before bulk onboarding. Future enhancements may include just-in-time provisioning of admin accounts, EPM integration for application control inside the VM, and ServiceNow integration to require a valid ticket ID for PSM connection. In summary, the CyberArk and Azure VM integration is complete, and the Azure footprint is now hardened against credential theft and unauthorized access.